Today we are solving log equations. Okay, so all kinds of logs. First, we're going to do regular logs. Regular logs have bases with anything other than e. And then the last thing is solve natural logs. Remember, natural logs, the only difference between a natural log and a regular log is natural logs have bases of e. That's it. Okay, follows the same rules that regular logs do. Okay. So how we're going to do this is anytime we solve, we want to get x by itself. That's what we want to do. Okay, but before we can do that, we have to combine, or another word that we used last week, condense. Combine or condense logs using the properties. All right. So using the three properties, product property, quotient property, power property, that's the first thing we're going to do. If we can condense, condense. Then we're going to change to an exponent. How do we do that? Using the e, using the loop, the e. Okay? And then isolate. Isolate, get by itself. And then the last thing is check for extraneous. Okay? We've done that before, but so let's do 1a. Let's do 1a here. Okay, so anytime you're solving, equal sign, to separate the equal sign. If there's an equal sign and you're solving, separate. Okay. So we have a log base of 5 and a log base of 5. We can combine those or condense those using the steps, the properties we used last week. All right, so we have to decide which property or properties to use. We can use one property, two properties. You can use all three properties if you need. So for this guy, first thing, power is when we condense, the first thing we always do is power. Is there a power I need to move back for 1a? Is there a power that I need to move back? There is, right? What's the power? 2, right? How do I know there is a 2? If there's something in front of a log, that means you need to move it back. So where does it go? It goes up here. So 3 squared. Okay. Now, I see that in between the two logs, I have an addition. Addition means I'm going to use the product property. So if I'm condensing, I go from addition to multiplication. Okay, so whatever is in the parentheses, I'm going to multiply. So I have two things in the parentheses. I have 9x and I have 3 squared. So what I'm going to condense is I'm only going to write one log. Since they both have the same base, I can combine them. Inside the parentheses, I have 9x times 3 to the second power. Okay. Now I can simplify what's inside the parentheses. 3 squared is 9 times 9 is 81. So it's really 81x. Okay, that's step 1. No more properties now. Now it's condensed. Step 2 said convert to an exponent. Okay, so how do we change a log to an exponent? We use the e, right? We use the e. That's what we're going to do, just like we did last week. Start with the base, go across the equal sign, and then come back. So 5 is the base, and then I went to the 2, and that's going to equal 81x. Since 81x is the only thing on this side, I don't need the parentheses anymore. Okay. Get x by itself. Well, 2 squared or 5 squared is 25, right? So how am I going to get x by itself? How am I going to separate it from 81? Division. Divide. So when I divide, I get 25 divided by 81. The only numbers that go into 25 are 1, 5, and 25. And none of those, except for 1, go into 81. So I can't reduce it. That's my answer. I am done. Okay, so the last step is to check for extraneous solutions. Extraneous solutions can happen when you get negatives or zeros. We can only have positives. And where am I talking about? I'm talking about in the pink. In the pink purple, I can only have positives in here and here. Well, right here, I have a 3, right? Or a 3 squared. That's 9. That's positive. So this guy's okay. But this guy I'm not sure about because it has an X as well. So what I'm going to have to do to check is take my answer. So is my answer positive or negative? Positive. Barely positive, but it is positive, right? It's less than 1. So if I were to multiply a positive number times a positive 9, would I get a positive or would I get a negative or would I get 0? Positive. So because it's positive, we're good. I don't care what the number is. When you're checking, the number that you get is meaningless. It only matters to me if it's a positive, a negative, or 0. If it's a negative answer or if it's a 0 answer, it's extraneous. If you were to get a positive answer, it's okay. So again, what is this times 9? I have no idea, but I know it's going to be a positive number. That's all I care about. Can't have a negative log. The reason I can't have a negative log is this. I'll show you. I'll give you an example. So let's say I have this, all right, something like that, right? So if I were to do the log trick, you don't have to write this down. Just look at, follow along. I get 5 equals 5, right? And then this guy's equal to 1, right? What if I were to change this and put negative 5 there instead? What power makes it negative 5? Would a negative power make it negative 5? No, right? Negative 1 power means I move it to the bottom. It doesn't change the power, or it doesn't change the sign. The answer is there is no number. There is no power that I can put here that would give me a negative answer. I can't change. Powers don't change signs. Powers either make the number really big or really small, but they don't change signs, right? Same thing with 0. If I were to put 0 here, what power would make 5 into 0? There is no power. I could make it into a 1, but that's as small as I can make it. I can make it into a 1, but I can't make it into a 0. So this guy right here can't be a negative, can't be 0. That's why. Because it doesn't work with logs. Okay? All right, let's try B now. Let's try B. Okay? It's a regular log. How do I know it's a regular log? Because it says log. It doesn't say ln, right? Regular logs just say log. LNs are natural logs. Okay, so now are there any powers I need to move? Are there any powers I need to move like I did the last one? Anything here, any powers I need to move here back? Here or here? Nope. How do I know again? Because there's nothing besides 1 here. There's a 1 here and there's a 1 here, but that's it. So nothing I need to do. Okay, so how do I combine them? How do I combine these two guys? division, right? It's subtraction, so I'm going to use division. 9x goes on top, 4 goes on the bottom. Change it to an exponent. So it's 6 squared equals 9x divided by 4, or 9/4 x. Okay, 36 is 6 times 6. How do I get x by itself? What do I need to do to get x by itself? There's a couple different ways you can do it. I got x is here, right? X is here. So how do I get rid of everything besides the x? Well, what is 9 doing with x? Multiplying, right? And then this means dividing the whole thing by 4, right? Well, let's just do the opposite of what we just said. We said this was divided the whole thing by 4, right? What's the opposite of dividing the whole thing by 4? Multiplying the whole thing by 4, yeah. 4 divided by 4, just make a positive 1. So when I multiply those two guys, I get 144. Now the only operation that's left over with the x is multiplication. So you divide. Divide by what I don't want. I want to keep x. I want to get rid of 9. And so you get 16. $16 is a positive answer. So if I were to plug in 16 up there in the pink, purple, would I get a positive number or would I get a negative number or a 0? Positive here for sure, right? 9 times 16 is positive something. And then this one I can't even plug in anything because I already have a 4. So there's nowhere to even plug in 16. So it's just positive 4. So I get one answer, and it's a good answer. It's not extraneous. One box on Delta Math. Hit enter twice, and you're good. All right. Okay, so now let's look at number 2. Okay. Same thing. Start with the powers. Are there any powers I need to move? No, it doesn't look like any powers. So let me combine them. I'm going to combine 3x squared minus 3 and 2x plus 2. I'm going to condense these two guys using division. Oops. Okay. Condense, good. Done. I only got one log and they're combined using division. Now let me use the E trick, the loop, to change it from a log to an exponent. So I get 2 to the 4th power equals the fraction. 3x squared minus 3 over 2x plus 2. Not 12, 2. 2 to the 4th, 2 times 2 times 2 times 2 is positive 16. Okay. Here's my question. How do I solve? What's my next step to solve for x? We've done this. Actually, we've done this before. I think we did in January, so it's been a while. What do we do? There's a couple different ways. So there's not just one way, but what's one way to do it? Multiply by the denominator, right? Yeah. This guy has a denominator of 1, right? We don't even need that but it does. Again, right? Using the rules we use on the first page, didn't we say divide by all of this stuff here? We'll get rid of the bottom. Let's do that. 2x plus 2. Multiply both sides by that. It gets rid of the bottom. You're right. It does. It becomes a 1. Because anything divided by itself becomes a 1. So now we have no more fraction. I have 3x squared minus 3. And then on the other side, I got to do distributive property. So I have 32x plus 32. Okay. What do I do now? How do I solve now? I'll give you a hint. You've done it hundreds, if not more, times. There you go. Use the steps on the board, right? Trinomial. Make it a trinomial. Set it equal to 0. So I'm going to subtract 32x from both sides. There is no x on the other side, so it's just going to be negative 32x minus 3. Minus 32. That I can subtract from negative 3. Okay. Trinomial. 3x squared minus 32x minus 35. It's equal to 0. Step 1 done. Step 2. Step 2 says factor out a GCF. It looks like 3 might be a GCF, but actually it's not a GCF. 3 is not a GCF. So it doesn't have a GCF other than positive 1. So let's go to ABC. A is 3. B is negative 32. C is negative 35. So we go A times C. So 3 times negative 35. Negative 105. B goes at the bottom. Okay, so now we're coming up with the two numbers that multiply to be negative 105 and add up to be negative 32. It's actually going to be the numbers you used earlier. It's going to be negative 35 and positive 3. They multiply to be the top and they add to be the bottom. Okay. Then we go to our multiplication box. We say 3x to the second power minus 35x plus 3x minus 35. Okay, so we're going to get an x and an x, and then this is going to be 3, and this is going to be positive 1 and negative 35. Okay. Now, we're going to have two answers. So I'm going to set them both equal to 0. So 3x minus 35 equals 0, and x plus 1 equals 0. So we get 3x equals 35, divide by 3. And then the other one is -1. So I get two answers, positive 35 over 3, -1. 35 over 3 is almost 12. It's like 11.7, 11.6. Don't change it to a decimal. Leave it like that. But what we're going to do is we got to check to see if any of those guys are extraneous. Well, -1 is the easier one because the -1's a whole number. So if I plug in -1 to the pink up there, any of them, if I plug in -1, let's say if I plug it into this guy here, if I plug in -1, I get 2 times -1, which is -2, plus 2, 0. This guy will make this into 0. That means it's extraneous. That means this guy here is extraneous. That means I'm not going to include it in my final answer. When you're checking, when you're doing the last step, you can round it. Don't round it when you put it in your answer in, but you can round it when you're checking. So like I said, it's between 11 and 12. 35 over 3 is between 11 and 12. So when you plug it in here, you can just kind of round it. So if I was to square, so up here I would square 11 or 12. That number is going to be over 100. And then multiply times 3. That number is going to be over 300. And then subtract 3. It's still going to be in the hundreds, right? Positive 100. So this answer is okay over here. If I was to plug in 11 or 12 over here, it would times 2. So it would be about 22, 24, something like that, around there, 23-ish. Plus 2 is still positive. So this answer is okay. 35 over 3 is okay because it doesn't give me a negative or a 0 up here. The other one does. Okay. So on Delta Math, you would only put one box. 35 divided by 3, hit enter twice, you're done. If you were to put both answers, you would get it marked wrong because one's extraneous. Okay, always check for extraneous with logs. Okay. All right, so do 2B now. Do 2B. If you haven't already started, do 2B. Okay, so combine. So I didn't finish, but I combined the logs using product property. So x minus 2 times 4x minus 7. Use the loop trick. And then I had to multiply. Since it was multiplication, I have to multiply. So multiply these two guys. It's a binomial times a binomial. So I use the multiplication box. Set it equal to 0. Now what I got to do is ABC. So A is 4, B is -5, C is 11, 15, sorry. So add up to be positive 44, sorry, multiply to be 44, add up to be -15. So you get -11 and -4. And 11. So you get 4x, x, minus 11, and minus 1. Okay. Set them both equal to 0. 4x minus 11 equals 0. X minus 1 equals 0. So I get 11 over 4, which is almost 3. It's like 2 point something. And positive 1. One of those isn't going to work. Which one is extraneous? 1. Yep. 1 is extraneous. Because when I plug in 1 to either of them, if I plug in 1 here, 1 minus 2 is negative 1. If I plug in 1 here, 1 times 4 is 4 minus 7 is negative 3. All I need is one of them to be negative or 0, and then it's extraneous. So the only answer you would put is 11 over 4, which is, like I said, it's almost 3. It's like 2.8. Okay. Okay, last thing. Last thing, we're done. Same thing. It's the same process. It's the same everything. The only difference is it's a natural log. That's the only difference. So first thing you're going to do is change the way it looks so that it looks like something we've done before. So what I'm going to do is I'm going to change ln and write it with a base of e. Same problem, but instead of ln, it says e. Log with the base of e. Because these are the same things. They say the same things. Okay, so these guys, we can't do properties because there's only one log. There's nothing to combine or condense. So we can't do properties. If we could, do it. If we could, you would do it. But these you won't usually. So we're going to skip that step. So the next step says isolate. We want to get this part the green stuff. We want to get the green stuff by itself. I have a 5 times in the front, and I have a negative 14 on the back. So we start, if we're solving, we start with subtraction addition. How do I get rid of that minus 14? Add it both sides. Add it to this and add it to 16. That makes positive 30. Almost. 5 in the front. I have 2 options. I can move the 5 to a power, or what's the other way to take care of 5? Divide by 5. Yeah, probably easier just to divide both sides by 5. That makes positive 1. So I get log with a base of e, 2x plus 5 equals 6. Logs all by itself. Now I do the loop trick. I get e to the 6th power equals 2x plus 5. E to the 6th power is actually a number. E to the 6th power is actually a number, and it's actually 403.4287935. But I'm not going to write that number down. The reason I'm not going to write that number down is because if you look at the directions, it says exact value. If I was to write this number down, I would have to round it. I'd have to round it. I can't round. Not allowed to round in my answer. You can round when you're checking, but not when you're rounding your answer. So I'm not going to write that number. So what am I going to do? I'm just going to leave it as e to the 6th. Just leave it like that. Okay? Solve for x. Subtract 5 from both sides. Divide by 2. Divide the whole thing by 2. You got your answer. Again, I'm not gonna put this in my calculator because it's not a whole. It's gonna be a long. Watch. E to the 6 minus 5 divided by 2. 109.2143967. I'd have to round that. But it said in the directions, don't round. So I'm going to leave it like that. That's the answer I'm going to put in. But before I do that, I have to check to see if it's extraneous. To do that, now it's almost 200. It's around 200. The value is around 200. So if I was to put 200 in the parentheses here, 200 times 2 is 400. Plus 5 is 405. That's positive. So this guy is okay, not extraneous. That's the only time I round is when I'm checking, because I'm just checking. It's not the answer. Okay, all right, so I want you to do 3B. Do 3B and we'll be done for today. Okay, so I got natural log by itself. I added 15 to both sides, divided by 3, changed it to an exponent. So I have e squared minus 10 divided by 3. That's my exact answer, right? This is the exact answer, because if I put this, I'm going to do it right now. I'm going to put this number in my calculator, and I'll show you. E squared minus 10 over 3. That answer is negative. Barely negative, but it's almost -1, right? Well, let's go check it out. If I were to plug in -1 here, would I get a negative answer? If I were to plug in -1 into that purple, would I get a positive, negative, or 0 answer? Three times -1 is -3, plus 7 is positive. Yep, you would get a positive answer. So even though this guy is negative, when I plug it in, it makes it positive. So it's okay. It is okay. All right. Okay, so tape in your notes.